Welcome. We have another problem again from electric dipole, and this time we need to find something else. And the problem says obtain an equation of the electric field lines of a point dipole with a dipole moment P in a polar coordinate system, the origin of which is at the center of the dipole, okay, and the polar angle is measured from the direction of vector P. I can see that, all those things. So I've drawn a picture, of course, and in this picture we have chosen we just take a polar coordinate system with the origin at the center of the dipole, center of the dipole, and the polar angle theta, and it will be measured from the direction of the dipole moment, as you can see in this picture. And let us decompose the vector P into two components, P parallel, that is along the radius vector, and P perpendicular along the transverse direction, that is perpendicular to R. And the field strength created by these components are here. This is E theta or E perpendicular, and this is E parallel, and the resultant is here, and it makes an angle alpha with E parallel, as you can see in this picture. And this small angle is d theta for another purposes. We simply know that the value of E parallel being 2p cos theta, that is 2p power parallel, divided by 4 pi epsilon naught r cube at a distance r, and E perpendicular is simply p sine theta, that is p perpendicular is p sine theta divided by 4 pi epsilon naught r cube. And since we got the values of E perpendicular and E parallel, you can easily find the value of tan alpha, and tan alpha can be perpendicular by base, and so E perpendicular by E parallel, tan alpha is E perpendicular by E parallel, and that will be nothing but, if you can see here, it will be E perpendicular divided by 2p parallel, and that is p sine theta divided by 2p cos theta. So tan alpha is equal to half tan theta. This is one of the relations we can write here. Also, for our purpose, we take two lengths, one along this E perpendicular, a small length ds, suppose that this length is ds, and it is along the E perpendicular, and this length is dr, because this distance is r, so we can write this distance dr and call this distance dr, a small distance ds is rd theta. And we can also write here tan alpha equals ds upon dr. We can also write tan alpha equals ds upon dr, and you can write tan alpha equal to half tan theta, and ds equal to rd theta, and divided by dr. And you can write something now. You just need to manipulate, everything is done, and you can write here simply as dr by r equal to 2 d theta by tan theta, or basically write it like half dr by r equal to d theta by tan theta, d theta by tan theta. And what can we do now? We can integrate it, and we will get the result as half ln r equals ln sine theta, that is the integration of d theta by tan theta, 1 by tan theta, that is ln sine theta, plus put the constant in terms of ln as ln c. It is a constant of integration, and we don't take 0 in logarithm, so Let us take an initial condition as let theta equals pi by 2 r is equal to r naught, and then put here, and you will write ln root r equals ln sine theta plus ln c, and then at theta equals pi by 2, this term becomes 0, and then r root r becomes ln under root r naught plus ln c. That means we got our ln c equals ln root r naught. I don't know the value of r naught. I simply put in an arbitrary constant, and we can solve further to write down it ln root r plus equal to ln sine theta plus ln under root r naught, and then you can write under root r equals under root r naught sine theta, and then you can write r equals r naught sine square theta, and that will be a result. This is the equation. This is directly proportional to sine square theta. That's all. We solved it. Thank you very much for watching.